Oh, wait, muted. Thank you, Arina. Yes, hi everyone, I'm Adriana. I'm a software engineer. I have more or less 14 years old experience in the area. And I work in different countries. Now I'm in Spain. And well, I've been working with Kafka for the last 7 years, I think. And that's why I'm here to give this talk to you today. So, well, I told a friend that I would be giving this TED talk, and she made a very strange face. I didn't get it, but now she actually asked me, Franz Kafka, are you talking about the writer? And well, this is the writer, and I'm not talking about him. I'm going to talk about Kafka, which is a distributed stream platform. And today I'm going to give more context about these points, which are fast, scalable, durable, and distributed by design. So keep that in mind for the talk. I assume that we have a very diverse group of people, some of you that doesn't have any knowledge from Kafka, and some of you already work or use it or know some bit. So I plan to have something interesting for all of you. Before starting, event streaming, right? This is a digital equivalent of humans' body's central nervous system, and Kafka is an event streaming. And technically speaking, is the practice of capture data in real time from event source like database, sensors, mobile device, and applications. And we can store and manipulate the data, process, and react for later retrieval. Apache Kafka is a very powerful tool and can make our life very easier when we have to deal with big volume of data. It's a distributed system which communicates via a high performance TCP network protocol. From this image, you can see that from Kafka page, it gives an idea of from the 100 Fortune companies, 8% of them are actually using Kafka. And you can see there is a very diverse market. There is bank, insurance, telecom, and manufacturer. In some of the use case, it's a very diverse option that we can use from Kafka. The first example is for messaging, so communication across different servers. It could be a replacement of any message broker that we currently have, for example, RabbitMQ, ActiveMQ. It could be used for tracking web activities. For example, if you want to monitor your user page view or interaction with your page, which leads to a lot of events and for later analysis. So that's a good use case because of the volume of the data. Also to track the alerts and application logs, for example, reporting operation metrics. So it could be used to build some KPIs for your application as well. And for data transformation, it's another very good use case for later reporting in real time. So assuming that, as I mentioned, that some of you may not have a lot of knowledge on that, so I'm giving some examples to put everybody in the same context. And this example is 3 applications. They need to talk to each other, and you have service 1, service 2, and service 3. And let's say that you have some configuration that needs to be shared through these other 2 applications. So ideally what we would do, it would create an API, and these service 2 and 3 could access the API whenever they need it. And if you want to replace that by using Kafka, what we could do, the service 1 would be the producer of this configuration, this data. It would store in the topic, and these other 2 servers could consume the data and do whatever they need without talking to an API from your service. So your service would be free to do other important things. Important to mention, this is async communication, so you send it and forget, and Kafka will deal with it. The other example is a common one that you have one service and you have a database and you have two other applications that needs to access this data, the same data with this database, which leads to a very simple problem that all these three servers rely on the database, which is not really a good idea. What Kafka provides is an API called Kafka Connect. And this API, you can connect to a database or different input data. And you can, based on that, it monitors your database. In this case, it's an example, any event change or any change in your database, update, insert, delete, will be monitored by the Connect and would create a new event to your topic. And these other two servers could just consume the data without having to talk to your database, and this makes things a bit better. In Kafka Connect, as I mentioned, there is a different input data that you can connect and a very diverse options to connect Oracle, MySQL, and other databases as well. Another good API or very handy is Stream Processor API. In this example, we have three applications. The application one do something and the output will be in the topic. The service two consume the same data and generates another output into another topic. The same goes to the service three. And it's very normal that we need to combine all these data and do some analysis, aggregation, or build something else on top of it, because you need two attributes from this topic and from the other, and then Kafka Stream Processor is there to support us to this kind of aggregation. So you can grow by key, you can generate filters, delete some data or ignore some data, and also consider time frame, for example. It's a very robust API and simple to use and to develop it. And this builds like the four kind of key APIs from Kafka. The other one is a Kafka admin. It's used just to see some consumer, some configuration, but it's more like for administration purpose. In this image, I want to give like a big picture overview on the Kafka architecture. Don't be scared by that, but is I'm going to speak in small details every piece of that later. So we already talked about consumers, producer, and then we are going to zoom in different topics. But here is important to mention that we have brokers, and the broker is a server for Kafka. So we do have three servers, and it combines partitions in each one of them. And yeah, this is the high overview of it. So the key important concept, I would say, it's event, because everything is event. And an event is anything that happened to your application. It's something that happened in your business. And an event is also called as a record or a message. And it is split by key. As you can see here in the example, Alice is the key event value, which could be anything, and the timestamp of when the event was created. And this is a very important thing to remember. Every event would be stored into the topic. A topic is like a folder for the file system, and you combine all the events on this topic in this folder. And the topic now it's partial or contains partitions, and basically here you can see that anything could be a producer for your topic. In this case, you have a mobile phone, you could have some car, you could have some external sensor or device that could produce something to your topic. And a message goes to a topic, and this could go to one partition, but not to more than one partition because it's not duplicated. It's a unique event that will be stored. And now talking the partition, it's a very important key because that's how Kafka actually can scale and how can process things faster. It's by partition, so you can create more partitions depending of the data that you have or the volume, or if you need to consume and parallelize faster. So in this example, we have one topic with 3 partitions. Every partition contains offset, which is the key for the event, and this is by partition, and they are also always appended into the end. So old methods are incremental, so they are starting from 0 and so on. And one message only goes to one partition. Now the offset, that's a word that you will heard a lot when doing or managing or doing consuming, producing is things for Kafka, because this is the ID for your message. And that message belongs to the partition itself. And whenever a new message arrives, this is committed to the partition, and this makes a confirmation that this was stored into the partition. And in this example, you have 2 consumers that are consuming the data, and they are in different offsets. In the consumer A is in the 9 and consumer B is in the 11, which means we do have 2 different applications that are consuming the same data, but they are consuming only a pace. So consumer A is a bit slow and consumer B is a bit faster. That also could be different reasons, infrastructure, or application A maybe had crash, and when it restarts, it continues from the latest committed offset. So it wouldn't restart from the beginning. And that's how it keeps track from the application, what consumed, what was producer. In this case, offset 12 will be the next message stored into the partition once it's received a new message. So we talk about topic, partitions, and the partitions are combined by segments. The segment is a sequential file that contains the range of messages in the order that they arrive. And the segment is essentially 2 files, one that contains the messages belonging to the segment, and the other one is the index of all offsets and the position that they are. And this makes way easier for Kafka to know where to manage the events, way to take it, and it's a really simplified way to access the data faster. And in this example, you have segments 0, 3, and 6. Why that? Because first message that arrives to the segment will become the ID of the segment. And that's why we have 3 segments here. And if a new event arrives, it would activate a new segment 9. And there is only one segment active per time, which means only one segment will be having writes, and the others will just be readings, because after the segment is done, no more change would happen to the segment. So these are kind of the key fundamentals of Kafka. I talk a bit about broker, topic, segments, and offsets, and producer. Now I'm going to start talking about the features that are from Kafka. One of the very important features is replication. So that's to make sure that you have your data there no matter what. And in this example, we have 3 brokers, and we have one topic with a replication factor 2. And in this case, means that we would have the primary topic and the primary partition, and the other 2 are being just as backup. In case this leader broker goes down, crash, or had any problem, then one of these other two partitions will be available to have the data. And by that, there are two ways of a replication, the synchronous and asynchronous way. Asynchronous way is when a producer sends some event to be stored into the primary partition, and all the followers partition would receive the data at the same time, but only when they store the message locally, they will send an acknowledgement to the leader, and that's when the leader would send back to the producer, I store the data, it's safe, you can continue. Otherwise, the producer would try to send the data again. The difference from the asynchronous way is that leader and followers would receive the data, but the leader would not wait for the acknowledgement for the message, for the followers, and would send right away to the producer, say, yes, I stored, you can continue, which could cause some problems in case there is a problem to storing one of the followers. So that would be the drawback on this option. Yes, so Kafka has two ways of managing his own data. And as when I show in the architecture diagram, there is a zookeeper, and this is kind of the starting way of Kafka to store or to manage election of leader, replication, topic, configuration, quota, and consumer information. It's an external application that you need to have running in order to have Kafka working properly. And these would be outside of Kafka, this application, and then Kafka and Zookeeper will be talking to each other, and then that's it. But that's not thinking about maintainability and different applications available. That's not a good way. And from more or less 2 years now, Kafka is trying to get rid of Zookeeper. And they are using now KeyRef, which is store the data internally into the Kafka instead of have an external service. And this, I think, since August last year, this option is available, and you can the broker itself would have the metadata, so don't need to have another application for that. And from the next versions from May this year, and would be deprecated Zookeeper. So I'm talking about Zookeeper because it's still something that is being used a lot. But from next year on, then this will be completely removed from Kafka from the version 4.0. Compaction. Now talking about how do we keep the data, and there is different ways of doing that. The basic one would be per time. You can define this for your broker, or you can define per topic base. In this example, we have a retention by the last 7 days. After that, the segments will be marked as deleted, and then only events from after that will be available to be consumed. The other option is by key-based retention, which means that we would have this data available for lifetime. And how it is done, basically, in this example, you can see that we have multiple keys. In this key one has multiple times, but whenever there is a new value for the key one, the order will be marked to be deleted, to be compacted, which means in the end, your output in your topic will be only this 6 value because the other are changes and they are compacted to be deleted. Imagine that you have an application that is distributed across the globe, and you have your Kafka servers on each region. And that's really good because you need to have the Kafka close to the producer and to the consumer to the data. But in order to do some analysis, business internally, it's not easy to manage that. So it usually would be done by using Mirror Maker, which you would synchronize the data to a central place, and then you can do whatever you need with Kafka in a single point without do much of effort. This comes by hand directly from Kafka. Now, talking about serialization. So you saw that there is events, and the events have key and value. The value can be serialized to anything that you needed, and these are the supported options from Kafka. Protobuf is designed by Google, is very tested, and has a really good performance. You could use, for example, in the JVM world, we use the gRPC, and it's protobuf, and then basically you could use the same message to produce to your Kafka, and that's a very good option. But depend of the use case and depend of the company, you can build from JSON, and then if you want more of contract, you could use message back. So those are the supported options from Kafka. One thing that is important to mention is that even serialization or compression that I'm going to talk now, both producer and consumers had to use the same one, which means because Kafka internally does not do any change, no, the events are immutable. And when you compress, you define which serialization you have and which compression you have. And this is very helpful because then this reduces the size of the message, then you don't waste, let's say, resources, and the change of the event, then it's faster. The available options are gzip, snap, and z4 and ztsd. The last one, it was designed by Facebook and has really good performance. So you can also don't compress if you don't need it to. And depending on the use case, actually, every version or each type would be best for you, depending what you need most. I read some papers and a presentation talking a lot about the ZTSD, but the downside of that only latest versions from Kafka support that, but still had a really good performance, reducing costs, which is something that always we have to keep in mind using Kafka. Should you use Kafka? Well, that really depends of your use case, because if you don't need why to use it, you need to think when is necessary to use it. And if your application to communicate a lot with other applications, and you have a really big volume of data, that could be a good indications to use Kafka. But you have to keep in mind of the trades-off and drawbacks on that. And then it also comes to option when not to use Kafka, because there are few options, and Kafka doesn't fix everything. So, and there are some things that maybe is not the best option for you as well. The first one that I would say, and I think is very important for new companies, maybe it will be if your application has a small scale, so we don't need a lot of volume, does not need the power that Kafka gives you. So you don't need to start from there. And other options now are depending of the type of your application. For example, low latency applications, when Kafka is a real-time application, but it's not a hard real-time application, which means that you don't have any guarantee of milliseconds that the message will be done. So in this case, if you really need this strict guarantee, then probably Kafka is not the best option for you. But there are also some other example here. And when we talk about deterministic system, like safety critical, like hard pacemakers, and that's not something that you should use Kafka to as well. And Kafka was designed to be using a small message size. By default is around 1 MB. But if you need to have bigger message, then probably Kafka is not the option, because this is anti-partner for Kafka, because there are some constraints on the latency and the throughput of the message, and big messages are not good for that. So that probably is not the best option as well. And limited resource also could go in the direction budget. Of course, this is also very important, because Kafka relies a lot on the resource and is usually expensive. When you have about complex transformation, then there are other options, which will be, for example, Flink or Spark, if you need to do too complicated transformation as well. But then why is Kafka so fast? As I mentioned already, the events are immutable, so there's no change. And the append, whenever there is a new event, it goes to append only, nothing happened on that after that. And as also the assumption is that Kafka works as a log. Something happened and that's it, right? Nothing should be happening after that. On this log, it's using actually Linux file system internally. That's also a good thing when you realize a lot. Kafka relies a lot on the page cache, which has a really good reads and writes. It's a really good reading about page cache in the file system, if you would be interested to know a bit more. And when I mention about the segments, for example, this is about the batching. The methods are batched and grouped by methods, and they has more efficient writes. And in the sequential I/O operation to reduce the seek time as well. So it's, you always know the position. You don't need to read everything and figure out. And you know already where to get the message. And also they compress it to reduce the network bandwidth, and the standardized binary data, which you would use the serialization as well. So in conclusion, Apache Kafka is a distributed streaming platform that provides a high throughput, low latency. It's fault-tolerant to data processing. And it was designed to handle a large amount of data in real time. And I hope I could explain today to you these keys here about fast, scalable, durable, and distributed by design. And that's it. Thank you. Now I think we have time for some questions, I guess, Adriana?
Yeah, sure. And let me actually read some of them. Okay, we'll get the recording. We will send recording in Slack channel, so no worries, you won't miss it. How can Craft communicate, and what is port numbers for Craft? There's a small technical questions about new way.
The question was how Craft work. Can you repeat, please?
How can Craft communicate, and how port numbers designed, I think, for
yeah, I don't have the complete details about how Craft works internally, but I do know that Apache Kafka did a lot of performance, and it has a really good performance using that. I think the most part that was essential for the definition to move from Zookeeper to Craft, it was to not have the dependency of an external application. And they are still kind of in the phase of testing that. It was just recently actually moved to production ready. And well, then probably we need to see how it goes, but I think it is very promising because that will be the final version from Kafka from now on. But I don't have more details, and to be honest, I don't know any company that is using this option right now. I just know by the papers and the presentations, and saw some talks online from Confluent mostly, just talking about the numbers, and they are promising, but I don't have the big details for that. Sorry.
Okay, good. There is another question, very interesting one. How do you fan out using Kafka?
How do you fan out? Could you elaborate?
Yeah. Hi, Adriana. This is Rajni here. So usually in event-driven systems, if you have one stream of data coming in, and if you had to send that, publish that to multiple systems, right? So think about an SNS and an SQS. You shove stuff on the SNS, and then you attach multiple SQSs on the SNS, and you can fan out. So the same data arrives in different, on different services or systems. How do you solve that in Kafka? Is that possible?
So as fan out, you mean to block the data to be accessed somehow? Because from my point, sorry, yes.
So what you want to do is the same, there's one source of data, right? There are topics in Kafka, and there's a stream of data that's real time entering this, being put on this topic, being published onto these topics. You then, so can you have multiple, so the way to fan out is you'd have multiple subscribers onto the same topic and consume the data. Can they consume it at exactly the same rate and get the ditto, the same streams? So if I had multiple systems.
This is actually guaranteed by Kafka. So there are two different things that you need to keep in mind. They produce the data, it's one application, and Kafka, it's another one, of course, but then the consumer can consume the data based on what they are needing. And that's really relevant to each application. So if you want to consume faster the data, and if you need really to consume really fast, what would be basically you could, and you have a really amount of data arriving to the topic. So you would parallelize, creating more partitions, and then you can consume this faster. That's would be the way of make things happen faster. And also, but the consumers, they are independent, they are different applications. So if you have one consumer that is getting the data and will get the same data as any other application, because they are the same information, nothing changed, doesn't matter which consumer are you. So imagine that you have a topic and you have 10 partitions. Only one consumer can consume from one partition. So ideally, you can parallelize this data from one thread, let's say, so one thread, but you can have one application that contains 10 threads and can consume this data from 10 times faster, let's say. Or if you want to guarantee the order, then you only have one consumer that let me guarantee, like it's not a strong word here, but from if you want to consume in the order that they arrive, it is doing that. But this tunnel that you are thinking about is for Kafka, they are independent. So it's distributed system. You have consumer, producer, and the storage. And if you want to just get this data, then you can just have more consumers to the same data, and they belong to the same group. If you want them to consume quicker the data, that will be what I think is what would be the best solution for that. Yeah, but so I don't know if that answers your question.
Yeah, so you could have two consumers getting the data in the same order, FIFO, and that's no problem for Kafka.
Yes, no, that's no problem. You can have 100 consumers and they can do even different things. So you can have your data that you put in your topic, but in my application, I want to just put some visualization, and maybe in the other application, I want to process and do some other analysis and output in another topic. They are completely independent, and producer does not know anything about that, and producer is total decoupled on that. Producer just know something happened, should be stored in the topic, and then Kafka will handle that. And for example, Zookeeper here just has the knowledge which consumer is consuming the data, where which offset was consumed until now. And now if you remove Zookeeper, then would be the QRef mode, but they are completely independent.
Thank you.
Anything else, Irina?
Yes. The question from Aaron. What would be used for low latency systems instead of Kafka?
So right now, for example, in my company, we are using SQS, like Amazon queues. So you could use that, but there are some, that's the thing that really depends. In our case, we have one consumer, one producer, and Kafka, it's more than that. So you can have multiple consumers for the same data. So you could just put in a queue and return if you are not want to use Kafka. That would be one option, random queue. Or then there is other option that you don't put in the queue, you send right away, but then you have a problem if there is communication problem, and then you have to retry and implement your own logic for that. So in that case, would be good to use a queue system if you are not going with Kafka, because if it's just essentially sending, communicate, and keeping for some time in your storage to process whenever you have time, then I think some queue system broker would be enough for that.
Okay, I think it's a good answer for low latency systems. It's interesting also what actually how low latency should be used, because you can also Google for disruptor which is for market making, and there is the mechanism that allows you to not use queue at all, but that's like ring buffers that use this for very, very low latency applications. Yeah,
that's really dependent on the use case, I think, right? What would be a low latency? What is your need? So that will be a different. For example, in other company that I work, we really needed to do things quickly, but it was everything that was done by Kafka was not relying on the user interaction. So if a user request received, then everything that was combined through application was done by application to application, not using any queue process, but was just REST or gRPC communication. And for the logging, tracking, business logic, then was being used Kafka for that. But then in different company that you need to have a queue just to make sure that thing will be reprocessed, and then it's not asynchronous communication anyway, it's asynchronous communication in that case.
Yeah, thank you so much. Yeah.
I just wanted to say that you're right when you said different companies deal with low latency, because at the end of it, it's the network latency that's the highest. So if if you want this data to go to the users in low latency, then you're thinking about edge systems and edge computing and putting servers on the edge so you can reduce the latency.
Yes. Thank you, Regina.
Okay, next question, maybe a bit simpler. Mohammed asks if you can explain again the concept of offsets.
Okay, let me go back to this slide. So offset is the key for your message. And then basically what you store in your so in your partition, you have your message. So if it's user action or user interaction to your application, the user clicking the button, the user scroll the mouse, the user change the page, every action is your event. And the offset would be the ID of your message in Kafka. And this offset it would be used when you are consuming the data. And that's how consumers and producers will know about it. So that's essentially the idea of the event internally on Kafka. And that's it. It's an incremental ID. It's starting from 0 and then goes until your all events you have it there. And one thing that's important is the committed in part. You only would have an offset if the message was actually stored internally. And this one is kind of a reservation of the next offset available. And if the message arrives, then it would generate officially the ID of 12. And this is used in the segments here for the index. And imagine that you have a consumer that you don't want to consume from the beginning. You just want a data starting from 5. And then how do you do? Then Kafka internally will know, okay, the 5, it belongs to the segment 3, and then checks in the index, which one, where is the offset 5, and then start in this position to read the message. And from there, then it consumes the data. So it will just a key base to be defined where to get the data and which data it is.
I think
So
it's
this
very
is
good
an
answer.
internal, sorry. So this is an internal thing, right? Offset which Kafka
Yes.
manages by itself.
Yes, that's the ID that an event has internally into Kafka.
You can
Okay,
also
thanks.
reset the value of the set that you're reading from. For example, you can say like, okay, I missed everything. I want to start read from the beginning but by default, if your consumer, for example, failed and your service failed and network is down, or I don't know, anything else happened, when it's recovering, it starts to read from the point where it's sent. And I worked with a version of Zookeeper, so Zookeeper actually stored the offset number, whereas the consumer last time seen. So consumer just continue to consume from this offset. And yeah, the magic that Kafka allows is to reset offset and repeat, like reread events again and again from different point of time.
Yeah, because what happened in your application, maybe you can start from the beginning or you can start from the end. So this is a configuration you add into your consumer. And if you process something that you store and you don't want to process again, you can just say, or if you delete your database or your data you want to reprocess at some point in time, then you can inform this, okay, you start from this offset, but this is a configuration in your application. So every consumer has this subset of configuration that Kafka provides, and the offset is one of the options that you can add into your consumer. But this is an internal configuration, internal detail for your consumer and your producer. But you cannot pass any value. This will be generated by Kafka. You just use it. Yeah.
Okay, thanks.
Good. We have 2 more questions. First, what would you mention the difference between topics in Kafka and MQTT? As I understand correctly, MQTT is MQ telemetry transport, which started in 1999. I'm not sure it's really, I think it's IBM MQ. Yeah, IBM MQ that historically came from. But for example, I wouldn't be able to answer this question because I read about MQTT for the first time in my life.
Adriana, Rajni here again with that question. I wanted to give you a little bit of context because like MQTT also has topics similarly based on publish and subscribe. And I wanted to know if you knew, you know, the the exact differences of why you would use an MQTT publish subscribe mechanism versus a Kafka, because both are really good and good in similar, similar ways, because it's based on publish subscribe. So I was wondering if you knew any differences between these two.
To be honest, no, that is also first time I heard of it, sorry. But I would say, like, for me, when I moved to Europe, it was when I started actually working with Kafka, and it was already available. It was already being used for so many companies and provided and supported. Even before, it was just on premise. Now it's on cloud as well. You can even build yourself. You can use an external provider as Confluence as well. So I cannot tell you on that. I can tell that at least Kafka, it's very used for a lot of companies, and you from the list that here from these 100 furniture or Fortuner companies, they are all using Kafka. So the top big companies in IT, they are also using Kafka. So I cannot tell the comparison. I just know that at least Kafka is very powerful. It is an open source, and you can use the cost that you have probably is more for the resource than managing internally if you want to on-premise, or if you want to get an external provider. And from the difference of what is a difference of a topic and Kafka. So Kafka is the combination of this infrastructure, right? So it's Kafka combines all these internally. So you have a topic is just where to store the data that you want. So this is kind of your table representation. If you want to keep this comparison with a database, is where it is stored, the logs, the events that you have. But all of that are Kafka, all consumer, producer, and are Kafka combined. But from the other ones, I cannot compare. I use right now in one of the teams or in one of the projects I'm using SQS. I use in the past RabbitMQ, which was not a good option, I can tell from our use case. But when I started using Kafka, I saw the power and the benefits using that. So you can basically do raw things, and you send an event, and whoever needs the data takes and transform and do wherever they need. So that makes us very decoupled from system to system, but is also very used for distributed systems. So if you have only one application, your kind of monolith, then you don't have communication to others, then what's the point of using Kafka? But if you do need in your monolith to build something and communicate to other applications, to other BI business, to do external analysis, Kafka maybe would be an option for you. But that really depends on the company, as I said. In my company, for example, we have a very diverse teams, and some of them are using Kafka, others are using SQS. So depends of things, or your use case, your problem will be a different answer, I would say.
Yeah, thank you. That I think the only difference that I can tell is like Kafka may be better for like using it as your internal, so you can also use it as your backend engineering, where you want to distribute data internally, not only externally. That's one advantage. You could do it with MQTT, but MQTT is usually very chatty. You use it for IoT. That's another thing, but I think in many different ways it does the same thing. And to be honest, like we working with a company that uses Kafka to give exactly the same data, the data we stream it over MQTT because it's low latency because of the protocol inherently, and they use Kafka. So yeah, they're quite similar, but I think like you said, Kafka is a little more powerful, where you can use offsets to basically keep track of. It's a combination of like an SQS plus MQTT in that sense. Thank you so much.
Thank you as well. Yeah, for me at least, the problem that I can see from the queues are that you have one producer and one consumer, and it's very normal that we need multiple consumers for the same data, and we have to build different queues to consume the same data just because at least SQS does not support that. And that would be an advantage for using Kafka, because then you just produce an event and you consume, or whoever needs consume that.
Yeah, perfect. Thank you.
Okay. So,
Okay, there is one more question. Do you know some cloud services that we could use Kafka straightforward? So instead of putting on Zookeeper or on Kafka, just get it from cloud. Yeah.
Yeah, one that is very powerful is Confluent. They actually are one of the developers of Kafka community, but they do also have their own Kafka version, and they do provide on the cloud. And there is actually a lot options. The only one that I know that I tested and I saw a lot of documentation, because I also went to a Confluent conference. It was their own provider, but then you have to think in mind of the costs, because of course they bring you a lot of value. You don't have to manage anything. You just create your cluster, press a button, and that's it. But it's external costs for you as well. But it's a good option. They actually provide some license if you want to just play around with Kafka and see how they're building their feature. You can just access, go to their webpage. I will share the presentation. You can access, and they have a lot of material for learning as well. And if you want, they also provide the license so you can try their product as well. So that's a good thing. And I tried, and it's kind of very good. And they have a really good administration place, because from Kafka, we just have this Kafka admin tool, which is not much, let's say. We do need a lot of more things. It struggle a bit to have this visibility. And on the Confluent page, they do have their administration, and you can see all the information easily. So that's one of the ones that I would recommend to give a try at least.
That's very cool. Thank you so much. There is some question from Mohammed, but Mohammed, please join us in Slack, and you can ask us questions in the backend channel that we have in our Slack. And we are happy to continue to give more examples and share experience with working with Kafka. And yeah, for today, oh yeah, okay, invitation link for Slack, I will share it right now. And
one thing that until you are doing that, these talks come with as a first talk, because just giving some basics to women who code, what's Kafka, what Kafka can do. And we were thinking about to create other sessions that would be more hands-on, to actually create some consumers, producer, and then also create some stream processor. So maybe soon we will have some event to do more hands-on. If you are interested, join the community and on Slack, so we can also plan that next talk or a workshop maybe.
Yeah, as we see many interests here and many interesting questions, I would love to continue to dive deeper in Kafka. And yeah, I'm really happy that you came today for this topic, that you listened. Thank you for your questions. And yeah, that's really cool. Please use Linktree I posted. So the first link there is actually a link to our Slack. And yeah, thank you so much again for coming. Thank you so much for this amazing presentation.